Happy to have you all here for our Science Cafe. Clearly an exciting topic for tonight. Lots of folks, lots of interest in understanding arsenic because this is certainly an area where we have a high prevalence of arsenic in drinking water. So we're very excited to have Drs. Bruce Stanton and Jane Disney with us this evening. Some of you may have heard an earlier Science Cafe that they've given on this topic, but this is kind of the next generation of they're working together. And so we're very excited that MDI BL, under Jane's guidance and with the involvement Bruce, has received a $1.2 million federal grant to really study this issue, but even more importantly, to do a lot of outreach with the local schools and teachers and really helping students understand how to deal with data. So when they're collecting important data, how to take a look at that. It's a whole project that Jane has been spearheading, and Anna and a whole group that working with Jane. So an exciting project that Jane and Bruce are going to tell you more about. They're also going to give you some important tips on how to look at your own well water if you haven't done that already. We have a group here from the Environmental Health Strategy Center. I hope I got that name right. And they have some test kits, so make sure if you didn't get one on the way in and you'd like one, that you can get one on the way out. And with that, I'm going to turn it over. I don't know who's going first. Bruce? All right. Fabulous. Thank you, Bruce.
Is it on? Well, thanks so much for coming today. It's such a beautiful day. Kind of feel a little guilty about having everybody here, but thanks anyway for coming. So I'm going to talk a little bit about the basic science of arsenic, how we get exposed to it, and what effects it has on our health. And then Jane is going to talk about a really exciting program that involves teachers and high school students and some partnerships with local colleges in Maine and New Hampshire. So you've probably all heard about this, drinking water, federal emergency declared in Flint, Michigan over lead in the water. You've probably also seen this, schools having high lead levels in their drinking water, despite the fact that it's required that the water be tested on a regular basis. It still comes up positive year after year after year. Cape Cod has a big drinking water problem. These are all front pages, I think, from the Boston Globe. So how many of you think our water is safe to drink? I'm going to disabuse you of that. How many of you have well water? Okay, wow. Keep your hands up. If you've tested it for arsenic, put your hand down. Okay, pretty good. Almost everybody. Dave.
Actually, we're using town water now, so.
Okay, so that's okay, but I'll talk to you about town water in a couple of minutes. All right. So how many of you saw this article from Consumer Reports? It just came out about a month ago. And basically what they did is it's the FDA's responsibility to test bottled water for contaminates like lead and arsenic. Okay? But the way the FDA does it, it says to the companies, you do it yourself. You'll be responsible for testing it. And what they found was, so the FDA limit is 10 parts per billion. So that is a parts per billion is one piece of toilet paper from here to London, England. That's how 1 part per billion is. 1 part per billion. So it's really small. So 10 part per billion is the FDA limit for public water supplies. And you can see that this, I can't pronounce it, but Pentophil, but Dr. Pepper, that's up around almost, I think, 15. And Starkey Water from Whole Foods, and several of these other companies have around 3 parts per billion. These two, this one in particular, is above the limit. And so this was a valuable contribution from Consumer Reports. And I actually got an email about a week ago about this. A woman sent me an email, and she said, when she was pregnant, she was pre-diabetic, so she was very thirsty. She drank 6 of these bottles a day. That's about 100 parts per billion of arsenic a day. And in our Dartmouth Superfund research program, we know that 15 parts per billion a day causes a reduced birth weight of infants, increased infections, viral infections, cold infections, and long-lasting effects. And the woman says to me, what do I do? My baby's now 3 months old. There's nothing you can do. It is too late. But that's one of the important things about the project that Jane and the group are doing, trying to make people more aware of arsenic in the environment and the adverse health effects that it can have.
We're talking about parts per billion is a ratio versus how much absolute she got.
So parts per billion is a concentration. It's micrograms per liter.
So she had 6 liters?
So she said she drank 6 to 10 bottles a day.
Okay, so that's a certain amount then that she got.
Yep.
Which is different than the concentration that you have up there.
Correct.
So what is the limit you should have per day?
So the average person between drinking water and food on average is about 10 to 15 parts per billion per day.
So she only should have had 1 liter of that stuff.
I would have said she should have had 0 liters of that stuff.
Well, because it went over 10.
Epidemiological studies done at Dartmouth, Columbia, University of North Carolina have shown that no level of arsenic is safe. And these are none. These are epidemiological studies that don't show cause and effect, they show associations.
All right, another question. What is the precision in measuring arsenic? Is it plus or minus 1?
0.01 parts per billion.
0.1?
If you have a really good ICP mass spec, it's about 0.01 parts per billion. Okay, so in 1974, the Congress passed the Safe Drinking Water Act, federal law to ensure safe drinking water. EPA set standards, that's what I just talked about, 10 parts per billion. There's about 155,000 public water supplies. Interestingly, it doesn't cover private wells and it doesn't cover bottled water, as I mentioned. Some states have legislation to reduce arsenic in drinking water. We testified in the state of Maine for a Drinking Water Act that requires when people buy or build a new house that the well must be tested and that the new owner must be made aware of that arsenic well water test. We also testified just recently this spring for New Hampshire. New Hampshire reduced the limit in public water supply from 10 to 5 parts per billion. And New Hampshire and New Jersey are the only 2 states that are below the federal limit of 10 parts per billion. Safe Drinking Water Act also talks about microorganisms like E. coli, fecal contamination, and all these other organics and disinfectants that can be in your water. And so it's required that these public water supplies measure for all these things. But the interesting thing is that every year there are tens of thousands of exceedances where the public water supplies don't meet the standards and the government says, don't worry about it, fix it when you can. And that's why I don't think, like Flint, right? Flint still has lead in their water. So, and they might post it like on the EPA site or they might post it on your town hall, but unless you know that the water in your public supplies exceeded standards, you're going to still drink the water. So I actually filter all my water, even on public water, but maybe I'm paranoid.
What are you filtering it with?
I'll show you in a couple slides. So this is not a really good test here, but the EPA, Environmental Protection Agency, list of substances that pose the most threat to public health. Anybody want to take a guess what the top 3 are?
Cigarettes.
Arsenic, obviously, because lead. Mercury. These are the top 3, right? So the ATSDR prioritizes the list based on the number of people exposed and how sick you get. So there are certain things like uranium that's very toxic, but not very many people are exposed to it, so it doesn't make high up on the list. And I'm showing these 3 icons because you can get arsenic in your drinking water. You can also get it in brown rice or anything made with brown rice syrup. And the reason is that the rice that's grown in southern United States is grown in old cotton fields that was sprayed with arsenical pesticides. And it never gets degraded. And when they flood the fields to grow the rice, the arsenic gets back in, it's taken up to the plant, and it actually accumulates in the husk, which makes the brown rice brown. And so actually one of our postdocs was doing like 5 power shots a day, and she was consuming about 60 parts per billion of arsenic per day. She actually was the first author on the study that showed maybe she shouldn't be doing that anymore. We also found it in some baby foods, and now the company is using organic brown rice syrup to flavor the baby food, but from a different source, so there's no arsenic in it. So we were actually able to get the arsenic exposure for these little babies. And during development, the worst time to be exposed, arsenic is during development. So the young and the very old have the biggest adverse effects if they're exposed to arsenic. So, okay, what kind of diseases does arsenic cause? Right? Flu, breast cancer, diabetes, IQ. Okay. Yes, pregnancy, bacterial infections, heart, and skin lesions. Here's the IQ one. Pardon me?
What about bladder cancer?
Yes. There's some epidemiological studies that have been done in New Hampshire by Margaret Carrigas's group that show a very strong association. I think, Jane, you're going to show a slide on that later. This actually was a project done by the Columbia Superfund research group showing that school children on Winslow, Maine have a decreased IQ that's about 5 to 10 points that's associated with drinking arsenic above the 5 to 10 ppb level. So this is a map from the United States Geological Survey that shows the arsenic in the United States. And you can see we're about here. The yellow to the orange are places where the well water is above 10 parts per billion. You can see other regions of the United States have pretty high levels, Central Valley, California.
What's the green?
The green is less than 3 parts per billion. The white doesn't mean there's nothing there, it just means there's no data. So this is due to a certain geological formation, and it's just part of the natural geology of our regions. Actually, in this island, it's just the northern part of the island, just this area here around the biolab. The southern part of the island is a different geological formation and doesn't have arsenic in it.
Bruce,
yes.
Can you measure plasma arsenic, arsenate?
So you can. There's several different kinds of arsenic, and when you drink the inorganic form, it gets metabolized in your liver to organic forms. The interesting thing about arsenic is it has a very, very short half-life. If you drink a glass of water with arsenic in it, it's gone within 12 to 24 hours. To tell if people have been exposed, you can either do hair samples and do ICP mass spec, or you can take toenail samples and it accumulates in toenails. However, arsenic has an epigenetic effect. We've done studies now working on laboratory mice, and if the mother mice drink arsenic, it lasts 3 generations. So great-grandchildren still suffer from those diseases that I showed you in the previous slide. So 3 generations. The arsenic effects last because of epigenetic effects, probably DNA methylation.
Are you saying that if you fill up a glass of your well water, let it sit for 12 hours, there's going to be less arsenic in it?
That means if you drink it, you pee it out in your urine within 12 hours. It doesn't accumulate. Mercury, however, accumulates, so different heavy metals have different ways to affect your health. So arsenic, it just gets metabolized and then excreted in your kidneys, in your urine.
Well, it has to be metabolized and have the half-life.
It turns out that the half-life of the different metabolites is different. The inorganic and any of the organic metabolites will all get excreted in the kidney. So the problem and the tricky thing about arsenic, it's odorless, tasteless, and colorless. So I have 2 glasses of water here. Which one has arsenic in it?
Both.
That has E. coli.
I don't know. I didn't test those 2. Amy gave them to me, so I'm trusting her. So this is a slide actually that Jane provided to me, and obviously this is Maine. So here's the island right here, and you can see that in Surrey and Blue Hill, these are 2 of the highest levels. Jane is going to show you some data from some collections that our students have done here, and you can see it's this area of the coast down the Portland area all the way up, and the Aroostook County, there's some, but it doesn't mean that it's low, it just hasn't been, right, Michelle, it hasn't been measured there. And you can see that reliance on private wells in Maine, it's about 56%, New Hampshire 46%, 10% of the wells have elevated arsenic. 10% in Maine, 20% in New Hampshire. And surprisingly, almost half of the wells have not been tested for arsenic. And that's one of the goals of Jane's SEPA program, to get the word out, have more people test, more people remediate, so I don't get any more emails from poor women who drink arsenic while they're pregnant. Yes?
So if you take a shower in arsenic, you're inhaling all the particulates, so you're filtering your water from the public supply, but do you not breathe when you shower?
So it turns out that at least low levels, the levels that we're seeing in this area, like most of the measurements are 50 or less parts per billion, occasionally a little bit higher. Those levels don't give you those skin infections that I showed. You have to go up above about a couple hundred parts per billion before you shouldn't shower in the water. And so it's very rare around here.
What about the inhalation?
It's pretty nominal. You probably take more arsenic in water or the food you eat. So the New Hampshire Department of Environmental Services recommends testing at least annually for bacteria nitrates and every 3 years for arsenic, radon, uranium, lead, and copper. And if any substance is above the recommended levels, you should confirm it before you do something. And then the issue is, and I think somebody asked this, what do you do? There was an article, I think this is from the New York Times, should you filter your water? And the conclusion of this, which I happen to agree with, is that yes, EPA rules may be too lenient. Some filters reduce lead, pesticides, chlorine, etc. And hormones actually found in regulated water supplies. So there is stuff in regulated water supplies. You know, nicotine, certain prescription medicines, etc. So I think you should filter all drinking water, and I'll show you a couple of slides in a minute. So I think this answers your question in part. So if your levels are below 250 parts per billion, both the Maine and the New Hampshire Department of Environmental Sciences recommends one of two things. Either you do bottled water, and I don't like that because it generates a lot of waste, plastic, it's expensive, and it's actually, as you saw from the Consumer Reports article, it's not tightly regulated. You can use point-of-use absorption filters like this. This is 01. Or you can do reverse osmosis, water pitcher filter. And the other thing is, once you buy a filter, you have to check it and maintain it because they don't last forever. If it's higher than 250 ppb, and then you wouldn't want to shower in it, you need to get what's called point of entry. That's where the water comes into the house, so all the water gets filtered. And that usually involves a reverse osmosis system that can be quite expensive, $1,500 to $3,000, and then you have to have a maintenance fee for the company to come and regularly keep it up to date. So a couple of years ago, some of our students did a study where they compared several different water pitcher filters, and actually since the study was published, Jane and I are working with some, and Anna, some of our students, in testing 2 new filters that have come on the market that claim to remove arsenic. And we've already done some preliminary experiments, and one of the filters that says that they're certified to take arsenic out, that doesn't take arsenic out. But we're going to publish a paper on that to let people know. So this is a study we did that we published a couple years ago, and we took 1,000 parts per billion, so really high levels, and one filter, 0 water, took it all out below detectable. This is Pure, Brita, Home Depot, and Walmart filters. And we ran a couple thousand samples through there, including well water samples, hard, soft water, all different combinations of the different chemical species of arsenic. And 0 was the best, and so I don't have any affiliation with 0. I've never spoken with them. They've never thanked me for the paper. They really should. But the cool thing about 0 water is that it not only takes all these metals out, like here's lead, takes 99% of the lead out, zinc, but it takes a lot of other things, like all these pesticides, a good fraction, and they actually go head-to-head with Brita.
So, Bruce,
yes, sir.
To clarify, this must be more than a simple carbon filter. It must be an ion exchanger.
It's a 5-stage filter, And it's proprietary, so I don't know what's in there. That probably looks like carbon, right?
Yeah, so they start with carbon, and then maybe there's a resin in there that takes the charge.
Yeah. I haven't quite taken a chainsaw to it and cut it in half, but the filter's about yay big. It's a pretty substantial filter.
Do you think that's a fair test, though? That's a lot of arsenic.
So to be fair, we did 100 and we did 10.
Okay.
And we found exactly the same. And the reviewers said, well, doing it in the lab isn't enough. You need to get well water samples. So we went out, we got well water samples, and I'm bringing the back of my car, and one exploded and flooded the back of the car with about 20 gallons of arsenic-containing water. But it's true.
So you did different levels.
Yeah, so we did different levels, yes. And the same ratios hold at all the different levels.
How does this filter work? Is that a thing you put water in and then pour it out of that?
Yeah, it's actually about this big, and it holds, I don't know, like
2 liters?
Is that what it says?
No, I'm just
okay. Yeah, 2 liters. Look, about 2 liters. You pour it in. It takes about 5 minutes to filter through, and then there's a little spigot here, or you can pour it. But it does a great job of taking a lot of really nasty things out of your water.
How often do you have to change the filter?
That's a great question. So the cool thing about this particular filter is, I don't know if you can see it right here, but there's a little meter here, and it's a TDS meter, total dissolved solids. And like here on the island, the TDS, at least for this meter, ranges between what, about 30 and 40.
You were doing 200.
You were doing 200? Okay. Well, at the cottage where I stay here, it was 46 this morning, and then I just tested it. So you can test it before it goes in and after, and it's just 2 little electrodes that just measure the conductivity of the water. And the nice thing is this is the only commercial one that I could find that actually has sort of a built-in test meter. So you can because it's going to depend how much contaminates are in your water, how many solids are there, how long the filter is going to last, right? In the back?
Where are these available for purchase?
Right, Amazon? Yeah, I just No, Amazon is great. Oh, and the other thing I forgot to say is the really nice thing is that you can recycle these filters to the company, and they'll send you a little bag, and you send 2 back, and they give you a $10 gift certificate on your next purchase. I know I sound like a shill here, but I believe in it. We have one at home. We give the dog water, coffee. Yes, sir.
Yeah, how does this compare to a backwash filter, which I'm assuming the container with the salt, that's reverse osmosis, which you spoke of?
Yeah.
How does that compare with that?
So this is about 40 bucks.
No, I mean I already have one. I'm just wondering.
You have one of these, or you have an RO?
The backwash filter.
Yeah, the RO works really well. I mean, if it's set up right, it works really great. But you have to be careful. If you're getting an RO system, it has to be tested on a regular basis, and the company that installs it has to make sure the filters are tested regularly. One of the, Joe Ayotte, who's the USGS representative in New Hampshire, so he's got a Ph.D. in geology. He got an RO system, it didn't work, and he worked with the companies for a very long time, and it turned out that his water had really high iron levels in it, and it kept clogging the filters. So he actually dug a shallow well and has a patent on it, but that's another story. I know. These Ph.D. guys, right? So I think to be safe, I would recommend that if you have a well, you test it. And it wouldn't even hurt to test your own public water supply because there's a lot of things in it. There was just an article in the New York Times about the PFAS in the water, right? Do you know about that? So these are the things that anti-stick things, firefighting foam. So near a lot of Army and other firefighting academies, the aquifers are contaminated with the PFAS. And there's no FDA or EPA limit on that right now. And it has really nasty effects. That's going to be the next big water contaminant from well waters and even public aquifers. And they have also all sorts of really terrible effects.
So do you believe the Bar Harbor water analysis for arsenic?
Well, it's the old saying, trust but verify, right? So I've actually tested it. And for the elements that we tested, they're all below the limits. So we looked at, what were the 12 things we looked at? We looked at iron, lead, arsenic,
molybdenum,
uranium,
beryllium,
yeah, manganese and magnesium, copper.
You're talking about the town water now.
The town water, yep.
But you don't agree with the limits.
So, well, you know, the New Hampshire State Legislature asked us what our recommendation was. And the difficulty is to go below 10 costs money because it costs a lot of money for these public water supplies to filter huge amounts of water to drop it from 10 to 5. Originally, the state legislature wanted to reduce it to less than 0.1 part per billion, but it would have cost literally hundreds and hundreds of millions of dollars to put the technology in the public water supplies to get it there. So we went back and forth with the USGS, the DES, and some of our studies, and there seemed to be an inflection point, at least in the epidemiological data, where around 5 parts per billion, the association seems to get a little bit steeper. So there was a compromise. But you know, if that cuts arsenic exposure in half, that's probably a good thing. In 2001, the limit used to be 50 parts per billion. So you know, it's a continuing process as more data comes out there and more is known about that. Jane, do you want to change your slides while I'm answering the last few questions?
I just was going to say, it used to be 50 parts per billion.
Yes, sir.
10 parts per billion.
Yeah. The 50 is an interesting story. There was a situation in England where they were brewing beer from malt that was contaminated with arsenic. And they found out the people who were drinking 1,000 were dropping dead. So they decided that they would change the standard. And they said, well, if 1,000 is bad, if we divide by 20, that's going to be good. So 50. And that's literally how they came up with it.
But a lot of standards are set that way.
Yes. Yes, sir.
You say a little bit about biological action. You established arsenic in, bad disease out.
Right.
What goes on between arsenic and, let's say, a garden variety salt?
So arsenic has probably 2 effects. One is an epigenetic effect. So what it does is it methylates certain genes. And when a gene gets methylated, it turns it off. And it seems to be, arsenic seems to be particular for genes that regulate our innate immune system. So that's our ability to rapidly fight off a cold or the flu or something like that. So part of it may be DNA methylation, but other genes seem, and nobody really knows. They thought maybe it would be like a heavy metal to, you know, cause DNA breakage or damage, and it doesn't seem to. A lot of people have been asking the question, and the only thing we can really, we know that it affects certain genes. We know that some of it is epigenetic versus DNA methylation, but there are other genes that get suppressed where they're not methylated, and we actually don't know how that works.
Okay, Bruce, I think arsenic inhibits the demethylases that take the methyl groups off, so that methyl groups are allowed to accumulate.
And that is right. Thanks, Ed.
So can towns afford to clean up the water consistently for schools like the one that you showed here? And also, I keep getting concerned about fruits and vegetables coming in from Mexico or from outside America where we don't know if things are regulated or not. But if they're washed in arsenic water, then is that the same problem?
Yeah, so if it's on there, arsenic is very soluble in water, so theoretically you should be able to wash it off. There have been a lot of food studies done both in the US and over in Scotland, in Ireland actually. That doesn't seem to be a major problem. The major food contamination seems to be from rice products, brown rice syrup products. That seems to be the major source.
So if you get brown rice from California, you figure that's regulated?
So it turns out, thank you for mentioning that. So it turns out that brown rice from the southern part of the United States where the cotton fields used to be, where they sprayed with arsenical pesticides, there's a lot of arsenic in that brown rice. Despite the USGA chart that I showed where there's a lot of arsenic in Central Valley of California, the basmati rice from Central California is the lowest in arsenic from U.S. suppliers. Like Uncle Ben is from Arkansas, really high arsenic levels. But Central Valley, California rice has got the lowest of all U.S. rices, including brown rice.
Even though they have high arsenic
in the water. But it's probably that the fields down south have huge levels. You know, can't offhand know what they remember there, but they have probably astronomical levels that just contaminate the rice, and the lower levels in the water and the aquifers probably aren't enough to really contaminate the arsenic, the rice from Central Valley. So I'm going to turn it over to Jane, and she can tell you what we're doing about this.
Yeah. Well, I think that you all realize what a big issue this is. One of the things that was striking to me in talking with Bruce is how his outreach team at Dartmouth has tried to engage people in the state of New Hampshire in testing well water. He and they have shared this story in communities throughout the state, and still it's hard to get people to test their well water, and there's lots of reasons why. But if a kid has to do it as a homework assignment, you know, it just gets done. So I've been known to shamelessly use children to my own environmental ends in the past, and I thought, well, why not now, given that this is such a serious environmental issue and can lead to such harm and such illness. And so we've been working with teachers and kids in Maine and New Hampshire, lots of different schools, and I'm going to share with you a little bit of their story, how we've been working to train teachers, what kinds of data the students are coming up with, what they're discovering, and I think how that is going to help to move things forward in our state and in New Hampshire as well. So first, I was hoping to introduce you to this SEPA project. SEPA stands for Science Education Partnership Award. This is a program at the National Institute of General Medical Sciences, and the idea is to engage K-12 students in doing some kind of scientific research that might help them understand better how science works and to be more scientifically literate, and also to encourage kids to think about science careers. So we applied for this grant together, Bruce and I did, in 2017. It got funded in 2018, so we're 1 year into this grant and working with kids. We had done an EPA project earlier as a pilot for this project, and so we knew it could work. We knew that teachers would be excited about this project, that their students would get the job done. And we realized that with a little more support, we could probably reach out to more teachers and more students. So we've been drawing on colleges and universities that are part of our IMBRI partnerships in both New Hampshire and Maine to try to partner scientists with teachers in accomplishing these goals and really move things forward. This is the website where you can find out about our project, but you can also find out about all the other SEPA projects that are going on around the nation. So I'm going to flip us out to the actual website. And I want to play a little introductory video for you that is sitting on our site. There's some pictures there you can see of our project and a couple videos. And this is a great introduction. It allows you to meet some of the teachers and hear from them how the trainings have been working for them and how the project has motivated them. I'm the Director of Education here at MDI Biological Laboratory, as well as the Director of the Community Environmental Health Laboratory. I'm the Principal Investigator on the SEPA grant, which is a 5-year project to engage teachers and kids in Maine and New Hampshire in monitoring their well water for arsenic. And this is a collaborative project with Dartmouth College. One of our main goals is to investigate the adverse health effects of arsenic and to
get people in the states of Maine and New Hampshire to test their wells and to remediate the arsenic so that they reduce exposure to this very toxic metal.
This morning the teachers are looking at bioassays, which are using plants and small organisms to look at the effects of contamination, for example. So we're using duckweed or lemna minor and daphnia, which is a water flea. And we have 4 different concentrations of arsenic, so 0, 10, 50, and 100 parts per billion. So we're trying to see the effects of the arsenic on the organism.
My name is Jane White, and I work at Tremont Consolidated School over in Bass Harbor, Maine. Being in the laboratory at the MDI Biolab is really exciting for me because it brings me back to the days of when I was a student. And I think as teachers, sometimes we forget being in that role as a student, and it reminds you how difficult doing science can be, and following directions and counting and making sure that the methods you're using are unbiased, because you have many people with different ideas looking at things with different perceptions.
Can I look?
Yeah. Maybe I'm crazy, but
no, I'm sure. Oh my God. I'm really excited about this workshop because I'm excited about working with students around real data that they can collect themselves and visualizing that data so that it's meaningful, and also connecting it to current events like health and water issues in their state. So I think it's a great way to be able to take classroom data and make it relevant to their lives.
Okay, now I just have to creatively get back to my PowerPoint presentation. Oops, I didn't mean to go from the beginning. Okay, here we go. So, you saw the word citizen science in the title of this grant project. And I don't know how many of you were here to hear my Science Cafe talk on citizen science. Maybe some of you were. I recognize some faces. But people don't always think about citizen science as happening in classrooms, but it can happen there. When students are working on projects that have real-world applications, when they're partnering with scientists from nearby institutions, when they're generating data that informs the Center for Disease Control or the Department of Environmental Services in New Hampshire, there's lots of reasons to use citizen science in classrooms. Citizen science transforms individual students. You can't believe what it means to a kid when they realize that they've made a discovery that could change somebody's health outcome, that maybe they have spared someone a case of bladder cancer because they took the time to do this work. Students can make discoveries that are important to the scientific community, but maybe even more important to their local communities. Students who have a difficult time learning in other ways often can learn through citizen science. So it's amazing how much the motivation to do the work can really help kids who otherwise are feeling disengaged at school, or they're having trouble finding meaning in the work that they're doing. I certainly think that the students doing this project are feeling like they're making a difference when they come into school in the morning. Citizen science connects students to the world around them. I was a science teacher at MDI High School for 9 years myself, and I can tell you it can be a little isolating for kids and teachers inside those 4 brick walls. But citizen science is a way that kids can be connected to what's going on in the world around them, and it inspires teachers too to think about maybe teaching a little bit differently. I've heard a lot of teachers say that this project has inspired how they interact with their students in other science projects as well. So as Bruce was saying, here's the thing that makes the project relevant and meaningful for students. They can see when they look at a map like this that the probability of arsenic being over 10 micrograms per liter in their well is pretty high up there in Maine and New Hampshire. Like, it's up there in the orange and the red range. The students only need to see that to know that being involved in this project is something that could possibly make a difference. We actually have Sarah Hall here tonight from College of the Atlantic. She's a geologist there. And she's taught us a lot about how arsenic really correlates with the type of bedrock that you have. So in terms of students understanding their own sense of place, that this place where they live has this type of rock, and that this metasedimentary rock is full of arsenic. And when water moves through it, it picks the arsenic up. So it's these kinds of educational tools that Sarah has brought to our teacher workshops, and this kind of information that teachers have taken back to their classrooms that's I think inspiring students to do something in their states. Likewise, if you look at cancer from arsenic exposure, you see this incidence of bladder cancer has been on the rise over the years for males and for females. And I have to say that when you dig into this article, what you find as the reason why it's on the increase, it's because of the types of wells that are on the increase. So we have a lot more people moving to these states. Most people are not on public water, and it's this increase in drilled wells that seems to correlate with these increases in bladder cancer incident. And this is something students can look at because a lot of them live in homes that have drilled wells. So this project really...
Is that because the drilled wells are going deeper into a certain stratum, and that's where the arsenic is? So a shallow well would be
not as high in arsenic, and I'll show you some of the student data that's quite striking. So this project in general is to really try to promote data literacy using relevant data that the students have collected themselves that's going to make a difference in their communities. All of the students and teachers then share their data with their communities. They have either science fairs, Jane White did that out at Tremont School. Teachers have held their own public meetings in their libraries and invited parents and community members, and that's what Michelle Brishkowski did. Pretty good, right? And also this network building that's going on between the teachers, the schools, and our local colleges and universities that are all partnered with either the Biolab in Maine or Dartmouth in New Hampshire. So this is school-based citizen science. There's only 3 of 100 and some projects in the SEPA program that are citizen science-based, and this is one of them, and NIH is very excited about the potential for citizen science in schools, especially to move the data literacy forward and to get kids excited about becoming scientists. And so this is part of this broader term that you've heard about, which is STEM education, which is science, technology, engineering, and math. This is something that's a priority in our country. That's why NIH is funding this work, not just at the K-12 level, but also, at the undergraduate level. And that at the end of the day, here's what we hope happens, that something changes in communities, that we've been able to go from what we call data to action, so that when the data are generated and the students understand it and they can communicate it, that somebody puts a filter on their kitchen sink and it reduces their exposure to arsenic, and then the potential for all of these devastating diseases that you've been hearing about. Right now, this is how many schools we're working with. So we've reached out to a lot of Maine schools. All of the teachers in these schools who are involved have been through our training program, like the one you just saw the video about. And we have a number of New Hampshire schools as well. And so you can see that we're getting some coverage here in Maine and New Hampshire. This year is the furthest down east we've gone. We have Machias Memorial High School coming in, and then we have some scientists at University of Maine at Machias that will be working with them and helping them. But we do have hopes to get up into northern Maine, working with University of Maine at Presque Isle and Fort Kent, because there's not a lot of data up there, and we just don't know what the risk is up there. I was going to show another little video, but I feel like maybe I'm running out of time. So you can go on our website. Actually, this isn't our website, but this is the SEPA website, and you can see more videos and pictures of our project on there. But Waterville High School in particular worked with public television and created an amazing video about their project, and I heard that it actually might be nominated for an Emmy, if you can believe that. Yep. So this is all of the samples. Every purple dot is a sample that a student has brought into the classroom and that has been analyzed at Dartmouth. We actually couldn't do this project without Dartmouth because they've got the trace element analysis core where all the water samples are analyzed. And at no cost to the SEPA project, all of these samples are analyzed, and it's tens of thousands of dollars in investment by Dartmouth in a project they think is that important. So you can see that when we had the EPA pilot for a couple of years prior to getting the SEPA award, we collected about 465 samples. But just since we started last September, we've collected another 700 and some samples. So we're getting a pretty good sample size here. And this is just a really rough look. An average doesn't tell you a lot because it's the outliers that are the real problem. But it gives you a sense that the kids in Blue Hill have a piece of work on their hands, right? That's their average. And Blue Hill's where we'll get the highest numbers. This is Bow High School in Bow, New Hampshire, and they're a close second. And again, those students have their work cut out for them to try to convince their community, we've got a problem, we all need to do something about it, and on and on. So this is the kind of data students are generating.
Where did COA do its sampling? Right on campus?
No, actually, College of the Atlantic is very interested because of Sarah's work as a geologist in the fault lines on Mount Desert Island. And this is Sarah's hypothesis that arsenic levels might be higher in wells that are in proximity to these fault lines. Stop me if I'm not correct.
and the rock type. So we may focus on the northern part of MDI, but that doesn't mean there's not a potential for arsenic in the southern portion as well, because there's rocks, metasedimentary rocks
there as well.
Yep.
Right, so actually we just submitted a supplemental grant to NIH to be able to expand this part of the project with College of the Atlantic, because not only are they interested in rock type, but are also interested in seasonal variation in arsenic level in wells. So we're going to try to get all those MDI high school kids to go back in a different season and resample and tell us, is it the same? Question?
Jane, when the students collect these samples, do you try to get data as well about the age of the well and the depth of the well?
We do. So we actually use our citizen science data portal called anecdata.org. Some of you have heard me talk about that. And the teachers have the students and their parents register their samples together at home. And they actually enter a lot of information about the well type. I'm going to show you some data right now, whether the water was filtered, whether they have a kitchen filter or a whole house filter. So we're trying to get a comprehensive picture of the metadata associated with the water quality data. Now, here's an analysis that the students did using a new software that we're teaching them about at tuvalabs.com. And Tuvalabs has been working with us on this project to help students really grapple with data. So it's an easy drag and drop software where the students can throw, one variable on the x-axis and another on the y-axis, and they can do this in real time. And so each of these dots represents a well that a student sampled, a student from one of these schools. And so what you'll see is that when the students filtered out all the data and took a look at the households that filtered all of their water or only their drinking water, a significant number of them still had high arsenic. And these are the kinds of things they're sharing with their communities. Now, it could be that these filters weren't ever designed to take out arsenic. And maybe people thought they would, or maybe they just didn't know they had arsenic, so they never put on the right filter anyhow. But there's a lot of people out there that may be feeling safe who aren't safe. And the students have this story to tell in their public meetings. Students, also intrigued by that bladder cancer paper, were interested in this idea that maybe the drilled wells would have higher arsenic, and look what they found. So of all the wells that were drilled or driven or dug, or a lot of people don't know what kind of well they have, which was pretty interesting. You can see that there's a lot of people that have high arsenic in their drilled well water.
What's a driven well?
Well, from what I understand, it's like a pipe that's, you know, just like driven into the ground as opposed to like a drilling apparatus that can get you much deeper. They're not as deep as drilled wells. And not a lot of people have them, is what we're finding. And, you know, dug wells are kind of interesting because although they may not have as much arsenic, these shallow wells tend to have more bacteria. So you're trading one problem for another.
What is a shallow well? What is the depth of
Oh, of a dug well?
Shallow.
Like a shallow well? I would say something less than 85 feet might even be considered shallow. Yeah. So here's project impact. This is actually a teacher at Bow High School was sent this email from a parent. And I'm waiting to see how many more of these emails that we get, but we may have to go out and get this information from families. Dan came home and told us that we were at 50 for arsenic after the first test. So we put a filter on the drinking water, and this second test has us at 0.02. So the family was able to resubmit a second test at Dartmouth, and they got their results, and they got the levels from 50 to 0.02. We never would have known if you hadn't done this program. So that's that impact, that community impact, that data to action. Something happened because these kids got up in the morning, listened to their teacher, and did their homework. And then they believed, like, yes, one person can make a difference. So I have the spotlight on Trenton Elementary for a very good reason. One, we have the Trenton Elementary teacher here. She used to work at MDI Biological, so of course she's doing the project. We have another teacher here who was at Surrey, and you saw how high the levels were at Surrey. That's Sarah Dunbar back there. She's now, as of last week, the new 7-8 teacher at Mount Desert Elementary School, and she will be back involved with this project. And we'll get some data from around the town of Mount Desert. Thank you. Anyhow, Michelle used a really interesting question, claim, evidence, and reason process to really walk her students through the data and get them to understanding. And they did a community meeting that was really well attended and a lot of fun. She had a couple of students that just didn't trust Bruce Stanton. Maybe it was I don't know. But anyhow, we have a video of his presentation on arsenic. And Michelle presented that to her students at the start of the project. And it got them thinking about using water pitcher filters. So they repeated his experiment. And what do you know? They started with nearly 100 parts per billion. And that zero water took it down. So they were pretty excited that they were able to validate your results, Bruce.
Well, the interesting thing is the Bernard and Britta did better in the students' test than it did in ours.
But they have an N of 1.
Oh, they do. They have an N of 1, yeah. I do find it interesting, Bruce, that when I gave it their project to them and I started looking it up, they came back to me like hours later and they said, we know it's going to be the 0 one because number one, you told us we had to do that one, and look what we found. They found your study published.
Yeah.
Funny.
But this is a great opportunity to talk to students about bias.
Yes, exactly.
Yes. So in the future, perhaps we won't tell them which pitcher filter is which. Anyhow, I just want to thank everybody who's on the leadership team for this project. And as you can see, it takes a village to have that many teachers engaged and to have that many water samples coming in. So Bruce and I are leading the projects in Maine and New Hampshire. We have coordinators there that we could not work without. Kate Buckman at Dartmouth and Anna Farrell, who you saw on the video. She is our coordinator here and actually the coordinator overall for the whole project. Kate Bailey has built all of our technology and actually edited the little film that you saw. We have a wonderful data literacy consultant from University of Maine who also works with Tuva Labs, and she comes to all of our trainings and she's available online for our teachers all the time. Amazing external evaluation going on. These people Karen Bielik and Bill Zolik are affiliated with the Skudik Institute, and they've been interviewing teachers, and they will be checking with students over time to see what their learning really has been. And we have our Chris Smith right here, who's our internal evaluator. And then we have this great external advisory committee, you know, that represents people from research, from education, people from other SEPAs, and then Sarah Dunbar, our local teacher. So it does take a village, but it is an amazing project, and I invite you to check out the SEPA website, our All About Arsenic website, that is our own project website, and that's it. So questions?
I noticed that the main DEP is not on that list of advisors. Why not?
Well,
water quality experts.
Yeah, they are. I think I could be wrong, but I would say Maine DEP does more surface water.
That's true.
And I think CDC, more groundwater. And we do work closely with the CDC here in Maine and Department of Environmental Services in New Hampshire. They're not on our advisory committee, but they are on the call with us. Okay. All the data. So one thing you'll find out, if you go on the anecdata.org site, where the students and parents are registering their samples and where all of the final water quality data gets entered, everyone enters a full data set, which includes coordinates of the property and their names and addresses and everything. But all that's privatized. You won't see that when you go onto the site. And so all of that data, though, so there's a disclosure form on there, like that for parents can check, and most parents check that it's fine, that all those data go to CDC or DES. So all these data are going to go into the big state data sets. These data are going to be used, which is great.
So we do have a regional meeting, and Andy Smith from the Maine
CDC, yeah.
CDC lab comes and works with.
Yeah, these are just the people that we've written into the grant and get a stipend. Yeah.
Dave, is it clear what type of filter one would need to purchase in order to exclude or reduce arsenic?
What kind of filter?
Now, what composition? Presumably a simple carbon filter would not do it. That's what most of them are.
Right.
Just
right.
carbon.
Right.
So you'd have to have something like the ion exchanger you have in a water softener, for example.
Yeah.
I don't know if there's some recommendation on it.
So the charcoal will take arsenic 5 out, but it won't take arsenic 3, and the balance between arsenic 3 and 5 depends on the pH and the oxygen content, so it varies from well to well. So like one of the filters claims that it takes arsenic 5 out. It's one of the ones that we're testing in the lab right now. And if you run arsenic 3 through it, it doesn't take it out. And it's usually average about 50-50 arsenic 3, arsenic 5. So that's why like Zero Water that has, it's a 5-step, it's proprietary, so, and I never cut it open. I'm not sure I would know what it was even if I did.
Yep, Anna has left some handouts on the little round table over here next to the food that has lots of information on water filtration systems, different companies, different resources that you can go to. We have some on our All About Arsenic website, and then the CDC website has a lot of information on filters too.
If we want to get our water tested, should we drive to Dartmouth?
No. So
you know a guy.
You know a guy.
Yeah, so I can say that the Environmental Health Strategy Center folks here were making some available to people, but you can also call the HETL lab at the state, and they will mail you a box like that, and you got to tell them what are all the variables you want looked at. They won't automatically run arsenic. That has to be asked for separately, and that drives the price of the test up when you start adding heavy metals. But the test they had out there was very comprehensive and did just about everything in the universe. That's why it was a little pricey, but they were offering them for $50, and it would cost $75 to get that box from the HETL lab. Yeah.
How often do you recommend people have their water tested? Some people say annually.
Well, I think annually for bacteria is not a bad idea, but that people are saying every 3 years for arsenic, but I think that the College of the Atlantic, if we get this supplemental grant, is going to give us some real insight into seasonal variability. And if I got arsenic one time and then didn't get it another time, I would treat it like it could happen anytime. But we're hoping to collect a lot more data on that and just get some of these kids and teachers to go back a second time in a second season that's drier or wetter, depending on when they did their initial test, and then also set up some of our own studies. Yeah.
What happens to the data that is collected when people send the water to be sampled to one lab or another? One would think that would create a huge database if it were properly and consolidated.
Yeah, so that's the unfortunate thing is, and I don't want to make any private water testing company feel bad, but you know, their data doesn't go into the state data set, and so if you're wanting your data to be part of a state data set, then the state lab is the way to go.
The data goes back to the kids who collect the water, and so it gets reported to that family.
Yeah.
And then,
oh, are you talking about our data?
Not in the project. I'm talking about individuals who send a water sample to a lab to find out what the content of the water is. What happens to that data? She's saying private companies that test.
I don't know where the private companies put the I don't know if they keep a database. I don't.
And the question is, are they asked to share it, and why not?
That's a good question for Andy Smith as to why they don't ask for it. But I know that if you go on the Center for Disease, the CDC website in Maine, there's a wonderful data tracker on there where you can look at incidence of Lyme disease and arsenic in well water and all kinds of things. And when you go into that arsenic data set, it's only from the state lab. It doesn't include private lab data.
and I think part of the reason is standardization. The state labs have a certain way, a certain protocol, a certain machine, so that the analysis is standard.
So does that mean that if we have a private company test our water, there may be variances, quality control?
Yes.
They're not regulated in any way as to how.
They are certified. They're regulated in that they have to go through a certification process. But there could be some slight variation in results that you get back. Although this trace element analysis core data, CDC and DES feel confident enough with that they would add it to their data set, is what we've heard.
So our lab is certified.
Yeah.
So it's a national certification.
Yeah. I'm more concerned about private labs that individuals have to send their samples to and quality.
You know, the thing is, some of these private labs also then put filtration systems on and then can come back and maintain filtration systems. And so some people want to work with the private labs because it's a one-stop shop service, and these people are continuing to work with them over time to see what the quality of their well water is. And the state lab's going to run your test, and then you have to decide what to do from there. Right. So you probably will end up with a private company at that point who may or may not be able to test your water but can install your filtration system and keep working with you.
So in short, if you've had a filtration system put in, the testing was not done by the state lab, it would be not imprudent to send your newly improved water to the state lab to see how the results match with what your company.
I would. Okay. Any other questions?
One quick one.
Sure.
So the incidence of cancer in Maine, and I think diabetes and a couple other major, above the national average. Do you have any data that you could overlay with where the hotspots for arsenic are, so that you could see if bladder cancer, for example, correlates on a zip code or county by county basis with where the arsenic is, so you could actually point to a place where intervention might actually change a health outcome?
So when Margaret Carrigas at Dartmouth is an epidemiologist, and she has done that. She has a birth cohort down in the southern region of New Hampshire where there's quite high arsenic. And that's where she's shown that the levels of bladder cancer are the highest in the state. Yeah, Columbia may have. I don't know. I'd have to look that up.
However, I believe Maine might maybe wrong, has a very, shall we say, mature population. There may be more tendency also.
There'll be a lot of contact.
Right.
Yeah, I think they try to correct for those things and those kinds of epidemiology studies, but yeah.
And then just one other quick one, Bruce. So arsenic is arsenic. You know, it's a free metal or a free iron. Is one thing, but does arsenic combine with some of these other toxins to alter their toxicity, like steroid hormones and things? There, drugs that are in the environment that could be toxic at a much lower level.
Yeah, so it turns out that one of the things that arsenic does is it's an endocrine disruptor. So any of the steroid hormones, Josh Hamilton at Dartmouth was the one who did most of the work on that. And the idea is that it shifts the dose-response curve between the action of a certain steroid hormone and the effect that it has. And it's got this weird effect where at really low doses it enhances, or low concentrations it enhances the effect on steroid action, and at higher doses it has the opposite result. We've never been able to figure that out. That's true.
This is kind of a speculation question. If you talked about arsenic, you can use selective filtration to pull various forms of it.
Yes.
Does that in any way form the basis for talking about remediation? And it's still pounded out by Uncle Ben's brown rice. What do you do when you have an identifiable brownfield that's arsenic enriched? Is filtration the only solution, or is any speculation about remediation there?
Yeah, the problem is that as far as remediation goes, there are actually people who are doing it. There are certain types of grasses that can be planted that will take. The Arizona Superfund group is working on this, where they're planting grasses in these brown fields that you're alluding to. And the idea is to take it out of the surface, because what happens in the Arizona area is these are arsenic from mine tailings, and there's a lot of wind there, and then the dust blows. And then people usually, people from low-income areas live near there. Low-income folks live there, and so they are the most impacted. So what the Arizona group is doing is planting these grass-like, I can't remember the name of it right now, but that take the arsenic up. And then the problem is, what do you do with the grass? But the idea is to get rid of the topical, the dust stuff that blows into these public living spaces.
We have students looking at that and studying the duckweed, because we set up these different serial dilutions for them to, and the teachers thought and the students think that high arsenic is going to really kill that duckweed, but instead it grows much better. And and so duckweed is used in septic ponds. It grows if you've ever gone up to the high school and seen that green all over septic pond number 1 in the back, that's duckweed back there, and it just loves all those kinds of toxic metals and what have you. But then again, that has to be collected and somehow buried somewhere else, because arsenic never goes away. You just move it around the planet, but it doesn't go away. It's a problem. Yeah.
Does Maine have contaminated soils from apple orchards, which we have had a lot of in this state that use those same sprays in the old days?
Yeah, so I don't know specifically about Maine, but in New Hampshire, people have looked in the orchards, and there's a lot of arsenic in the ground from the arsenical pesticides. And I would imagine it's the same thing in Maine too. I don't know specific examples in Maine.
So if you were gardening on those soils, that might be a concern, like growing rice on them.
Yeah. Well, the interesting thing is a project that's being done in Dartmouth right now shows that if you grow rice in an unflooded field, the brown rice doesn't accumulate as much arsenic, but the yield is lower. And now they're working on trying to do seasonal flooding, to do a minimum amount of flooding to reduce the impact. And also our group is trying to breed strains. They won't allow GMO for rice plants, but one of our investigators is trying to breed plants that still have good productivity, but don't take the arsenic up. She was a selected National Academy, actually.
Don't apple seeds have arsenic naturally?
Cyanide is...
Cyanide or something. They have something in it.
Something bad.
Some bad.
Being signal.
I'm just
Okay.
Maybe one more question.
Okay.
Okay.
We'll be around if people have more questions.